Okay, everyone, welcome back to the FY22 CINR webinars. Just as a quick reminder, at the end of this session, if you do have any questions that come up after the webinars are over, please send your questions to neup@inl.gov. And now we're going to have a presentation by Mike Rime, DOE-NE, on the FC-3 Workscope. Go ahead and take it away, Mike.
Okay, I'll just check one more time to make sure you can hear me. Am I good?
Yep, sounds good. Thank you.
Okay, great. So good afternoon, everyone. I'll be presenting the Materials Protection, Accounting, and Control Technologies scope. So if you have followed us in recent years, this should look fairly familiar, especially last year's. We've kind of made some adjustments over time to try to solicit proposals in specific areas. But overall, the goal of the Impact campaign is to support advanced fuel cycle technology developers and to address international and domestic nuclear materials control and accounting requirements. So that's a very long-winded way of saying we want to build tools and get them in the hands of people who can use them. Of course, the focus is accounting for nuclear materials, specifically S&M, actinides, things that are of interest to the safeguards community. I'd also point out that we are very much a domestic program. We are focused on enabling the domestic deployments of fuel cycles. However, by necessity, a lot of the international IAEA regulations are different, but quite similar to things that we have to address domestically. So NNSA is the office that handles IAEA and international safeguards. We are very much focused domestically, but by necessity and by cooperation, we work with them closely. So how do we pursue this goal? Really, we want to develop, demonstrate, and deploy technologies, analysis tools, and integration methods. So we're really looking to take things that are rough. I don't want to specify an exact range, but we're looking kind of at the mid-tier TRL level, and we're looking to take things to where we can actually demonstrate them in a lab setting and then deploy them in a real-world or facility setting. So that's our main strategy to pursue our high-level goal. So we develop advanced MC&A technologies, some of which I will mention in a minute, as well as analysis tools and modeling, ways of system engineering almost to improve the efficiency and effectiveness of safeguards and security. So that's kind of our main goal. In addition, as I mentioned, we work very closely with other government agencies, industry, regulators. We want to understand what the needs are, what the emerging technologies are in advanced reactor fuel cycles, the types of fuel cycles that will be needed for advanced reactors, for example. We want to understand all these things early so we can, put in effort to developing safeguards and security R&D that will meet these new emerging technologies in the nuclear world. Our focus areas, actually this chart, I'm going to test something here. Yeah, okay. Our focus areas, we're really in these two categories, enrichment and fuel fabrication and the recycle. So both the front end and back end of the fuel cycle is where we're focused. There's an office, NE5, that has their own CINR call for proposals that works on advanced reactor safeguards. So we are very much fuel cycle focused. Currently, we don't really have plans to work on interim storage or geologic disposal. So we're sticking with projects both in the front and back end, kind of bookend of advanced reactor deployment. I guess I'd also just mention this could include, fuel fabrication as well as options for recycling or new waste streams that are associated with advanced reactors, even if it's not full reprocessing, if it's just associated with a new reactor type. So that's sort of that's how we overlap a little bit with some of the advanced reactor designs that could have online processing. So what are the main challenges that we face in this area? Really, there's a lot of new technologies that are being pursued, like I said, with advanced reactors and their associated fuel cycles. The environments, this is not a simple counting spent fuel rods. Well, I shouldn't say it's simple, but it's not it's not a straightforward counting LWR fuel assemblies that has decades and decades of experience. So we're talking about potentially, in some cases, for advanced fuel cycles, like I said, online processing. You're talking about environments where it's high heat and high radiation, new product or waste streams, potentially HALEU fuel fabrication. Most of the advanced reactors are planning to utilize HALEU fuel, as well as just being able to work in a kind of a new era of technology where we want to push the envelope a little and not just count things after the fact. We're looking to do online process monitoring and real-time measurements. There's a lot of ways that new technology outside of the nuclear realm can be applied to safeguards in a novel way. So we're trying to pursue things like that. And the second bullet here, of course, so this will require a combination of technology and tools and integration methods to sort of do the things I was alluding to, where we want to increase accuracy and precision of measurements, but it's also possible to measure more things or to combine things in a way where we generate more data using the same measurements due to either real-time or online monitoring or kind of synergistic ways of combining data real-time to get more information from a system, and not just make measurements or take things to a radiochemistry lab after the fact, but actually like I said, lean forward in our measurement approaches and do more things real time. So just a shout out to a couple of things we've developed over the years on this slide. Both the microcalorimeter gamma spectrometer at Los Alamos, that was a NIA project, and the triple bubbler system at the HFEF in Idaho. So these are a couple examples of specific technologies we've developed in recent years. And finally, this is sort of a summary slide. MPACT seeks to develop and demonstrate technologies that enable domestic, and that is the focus, domestic nuclear materials management and safeguards. And I guess here the phrase emerging nuclear fuel cycles is a nice way of saying we're really focused primarily on advanced reactors and the sorts of fuel cycles they may require. And MPACT develops tools and security features that work with the design and operation of these new fuel cycles, and they fill and account for technology gaps associated with these fuel cycles, some of which I think we don't completely have a good grasp of yet. So we're always looking for new areas that will require a renewed effort and focus on safeguards with these fuel cycles. And as things develop, we're going to change our priorities to make sure that we're covering the safeguards and security needs for advanced reactors and for advanced reactor fuel cycles in support of NE. So this could include things like fuel fabrication, as I mentioned before, nuclear fuel recycling, bulk holdup and bulk facilities. This could include short and long-term storage and waste. I mentioned before that's not our main focus right now, but honestly, the waste problem is definitely an issue that's going to have to be tackled when it comes to advanced reactor fuel cycles. And as I mentioned also, waste streams, new waste streams, or at least, I guess, interesting waste streams associated with some of the advanced reactor designs, that's definitely going to be on our radar at some point as well. So in short, we're requesting applications to develop innovative materials control and accounting technologies and tools. We want to increase the accuracy, reliability, and efficiency of quantifying nuclear material tracking, possibly online monitoring or in real time. And in general, just tools that will enable process monitoring for safeguards and security. Yep, so the POCs are at the bottom here, and the award 2 years, 400,000 is our target number. And thank you very much for listening.
Okay, let's see. It looks like we have at least one question here. It says, is modeling and simulation of interest? And if so, what level of theory are you looking for?
I'll attempt, so it is of interest. We have funded in the past some modeling efforts. Generally speaking, because we have a limited number of awards in general in the last couple of years, my preference has been a little bit more to actual sensor development, but that doesn't preclude the option that we would fund a more of a system engineering or modeling kind of study. I don't really know, I'm not an expert. I know more about radiation detection than modeling, but I would say that the types of models we're looking at tend to be, they tend to take existing platforms and sort of integrate them together or use like a systems engineering approach. So it's more, it's definitely not first principles. It's definitely not really, what's the word for it? Some of the other offices, like Office of Science, you know, they do they do modeling that's much earlier in the development stage. I think we're probably looking for more of an applied approach to modeling a system or a facility. So I hope that helps, but I know it wasn't maybe the perfect answer.
Okay, thank you. Next question. Is this Workscope for 2 years at $400,000 or 3 years at $600,000?
So I think, so 2 years at 400,000 is what we're looking at. But that actually makes me wonder, wonder where those other numbers came from. Like I wonder if there's a disconnect. A disconnect between me and the CINR. So let me talk to them offline after this.
Okay, thanks, Mike. Next question. Are you mostly interested in uranium inventory, or are you also interested in fission product accountancy?
Both. Yeah, definitely, definitely fission products. You know, yeah, plutonium, uranium obviously are the most relevant, but anything really spent fuel, fission products, and really just actinide measurements in general, especially real time. That's the focus. In the front end of the fuel cycle, you know, for fuel, I mean, then you're talking those projects by necessity are probably, you know, going to be focused on uranium or processes that involve, you know, fresh fuel. So it's going to involve uranium most likely. So yeah, hopefully that helps.
Mike, I'm just looking over the draft work scopes and realizing that the draft work scope does have 3 years at 600K. So for all applicants, we will resolve that discrepancy in the final draft of the FOA. So please stay tuned in that regard.
Yeah, thanks, Drew. Yeah, I'm not sure what happened there. I'll work with you to fix it.
Okay, thanks, Mike and Drew. Next question. I was going to ask the opposite of the first question. Are you interested in experimental only approaches or incorporating modeling and experiment?
It's definitely of interest to combine the two. In the past, there have been some proposals, some well-received proposals that have done both. Sort of I mean, there are different ways to combine those things, but you know, people have definitely sort of done I don't even know if this is the right term exactly, but sort of a proof of principle by modeling, and then use that as the basis for improving or developing a system or a detector. So I think the two can work really well together, and we would encourage that in applications. I think sometimes that can be tricky in terms of how the application is written. So if you're going to go down that route, I would just encourage you to be very specific about, I guess for lack of a better term, when the modeling starts and stops and how the results are going to impact or help with your system or detector design. So if you can be very clear about how the two interact in your proposal, it could be potentially a very strong proposal.
Okay, great. Thank you. Is there a particular interest in any specific modeling tool, like something in the Vera suite or the Moose suite?
That one I would have to check and reply after the fact. I don't think there's a particular modeling suite that we've looked for, but there have been a number of proposals that have used, some of the reactor codes. There have been some of the codes at the national labs, that are more detector focused. So I would say whatever you're comfortable with is, as long as it's relevant to the proposal. It's not that we would rule out or like judge a proposal more harshly based on the code selected, so long as you're choosing the right tool for your project.
Okay, another question kind of along that same line. Could you also propose a new simulation platform to be used for the project?
Sure, I wouldn't rule that out. I guess I would just emphasize. I guess this is sort of implicit, not explicitly ruled out in the call, but I am a little more cautious about, because I am looking to develop, demonstrate, and deploy technologies. I am more receptive to things outside the box when it comes to lower TRL or like newer things that are being developed, R&D projects. However, I still do sort of have an eye towards things that are able to, really kind of reach some kind of end state with the NEOPS, and then even potentially be picked up or considered by another lab or another user or a follow-on NEOP project in the future. So it's a roundabout way of saying we're open to that. I think it could be a good idea, but I'm a little cautious about funding, I guess, for lack of a better term, very unknown or experimental models because of our kind of applied approach and our limited number of awards that we have every year.
Okay, thank you. Next question. When you mention materials protection, do you mean replacing with new materials or protecting the ongoing materials with some sort of coating or deposition?
Oh, I see. Okay, so I think unfortunately, so the answer is well, I guess it's protecting. So in a facility or in a nuclear fuel cycle, protecting the S&M, accounting for it, controlling the facility or the technological process. This is like a applied, hands-on. Like this is more referring to like what the regulators are looking for, not a coating or a protective like triso fuel or something like that. Like this is very much, this language is intended in our title. The language is intended to be looked at from a safeguards and security point of view. So protecting, accounting for, and controlling S&M in fuel cycle facilities.
Okay, thank you. Next question. Is the focus of this topic solely on applications to emerging fuel cycles?
So that's kind of a tricky question because, there aren't really, I want to say yes. I would say we are primarily focused on technologies that at least can be used for emerging fuel cycles. The problem, of course, is that there aren't advanced fuel cycles per se. So a lot of our projects, they could be dual use. If you design a detector, obviously it could have dozens or hundreds of applications. But as long as you can demonstrate that it would improve safeguards and or security for like an advanced reactor fuel cycle facility or a bulk material processing facility, like a molten salt loop or some kind of like aqueous or pyroprocessing facility. I mean, I think it's kind of a gray area, so I wouldn't be too concerned about it. But we do ask that in the proposals that you emphasize the fact that it could be used for emerging or advanced fuel cycles, whether that's front end or back end.
Okay, great. Thank you. It appears that that's the last question for this session.